All right. Domain of composition of trig functions. This is when the two functions are the same, sine and inverse sine, cosine and inverse cosine, tangent, inverse tangent, okay? If the inverse function is on the inside, if you remember when it's been a while since we did composition of functions, the domain is restricted by the input function. So it's restricted by this function here. So if this value here is between -1 and 1, then if you take the sine of the inverse sine, you just get plain old x. If this is between -1 and 1, cosine of inverse cosine is x. And this falls back on what we just talked about previously, where in order to have inverse sine and inverse cosine, this has to be between -1 and 1. Same thing for inverse tangent. The domain for that is all real numbers, and so whatever is inside here, you end up getting just x. So if the inverse function is on the inside and you have the regular function on the outside, it just is equal to x. So as long as this is -1/4 between -1 and 1, then the sine of the inverse sine, those basically are canceling each other, and it's equal to a -1/4. Tangent, you're pretty safe. As long as x is all real numbers, then they cancel, and this is equal to a pi/3. Inverse cosine, the domain of inverse cosine is from -1 to 1. So this itself doesn't even exist. And so what ends up happening is you get in a pattern when you see those that, oh, this is just my answer. But it has to fit that domain. And so in this case, this doesn't even exist, so the whole problem does not exist. And now we're going to switch it up. So we have f of f inverse. The other part of this is going to be f inverse of f, okay? It equals x when, now the domain is changed to the restricted domain here. If this is between -pi/2 and pi/2, then it's equal to x. For cosine, if it's between 0 and pi, then it's equal to x. And tangent, if it's between -pi/2 and pi/2, it's equal to x. If it's not, then you have to go through and do the process, okay? So this first particular one, we have the tangent of pi/2. Well, the tangent of pi/2 is undefined. It's not even in our domain. So you can't take the arctangent of the tangent. And so this does not exist. Sine. The sine of 7 pi/4 exists, okay? 7 pi/4 is in quadrant 4, but this is not in our domain of our restricted function because we're dealing with the inverse functions. So what we're going to do first is we're going to figure out what the sine of 7 pi/4 is. Well, the sine of 7 pi/4 is a -square root of 2/2. Then the inverse sine of -square root of 2/2 would be equal to a -pi/4. So if this value is not within this domain, then you just have to go through the process and figure it out. And here, 3 pi/4 fits within that restriction from 0 to pi. And so cosine inverse of cosine of 3 pi/4 is just going to be 3 pi/4. And these are nothing new. These are all coming from, again, this sheet. So if you learn these restrictions, this is what carries through on all of these, whenever these inverse trig functions are involved.